I wanted to introduce a specific circuit to you in this video, and the circuit that I wanted to introduce is called a adder. Okay, so it's an adder circuit. Now, as the name suggests, an adder circuit adds two numbers. So if you have two inputs, let's say A and B, that you are giving in, uh, so you'll have four combinations, right? 0, 0, 0, 1, 1, 0, and 1, 1. Now, if you add these two numbers, you get two outputs called the sum and the carry. Okay, represents sum and C represents carry. So let's just see how the outputs work. So if you add A and B, and uh, if you add 0 and 0, what's the answer? It's 0, right? So you get the answer 0 and 0. If you add 0 and 1, the sum is 1 and the carry is 0. There is no carry over from there. If you add 1 and 0, you get the same thing. You get 1 and 0. If you add 1 and 1, the answer is 2, right? But you can't represent 2 in binary. How do you represent 2 in binary? You write 1, 0. So the sum becomes 0 and you have a carry called, which is 1. So the result here is 0 and 1. Okay, so this kind of an adder, which takes two 1-bit numbers and adds them up and gives you a sum and a carry, is an adder, but it's more specifically called a half adder. Okay, the reason why it's called a half adder and not a full adder, we'll look at full adder in a moment. It's called a half adder because you don't have a carry in the addition. So in a full adder, you will have A, B, and a carry in, and you add those three things to get the sum and the carry. But in a half adder, you only have A and B. Okay, so how does this circuit look? So let's just take a look at how this circuit functions. So basically, a half adder is a digital circuit which takes two inputs A and B, and gives you a sum and gives you a carry. Okay, that's what a half adder does, and I'll leave it as an exercise for you to actually design the circuit using logic gates.